Hello students, welcome to Vyas Edification Kota. In this series of NCERT discussion, yes, it is time to continue further with mathematics class 12th discussion, and we were seeing something called determinants in the previous session. Yes, determinants, and we were on chapter 4, and it's time to see exercise number 4.6 as you can see behind me. Now 4.6 exercise is based on solution of system of equations. Once again, a very important concept from the chapter of matrices and determinants, that is solution of system of equations, and a lot of questions are framed from this particular exercise, or you can say based on this exercise. You consider the board examination or you consider the JEE main, JEE advanced examination, there are questions asked consistently from the topics covered over here. Now this particular exercise, as it is covered in the NCERT, deals with a particular type of equation only, particular type of equation set only, or solution set you can say. Whereas the JEE main and JEE advanced people move beyond that, right? They talk about further different types of solution sets as well. So what do the NCERT people cover and what else could we cover? We'll be talking about those things first of all, but let's talk about the question. The first question says, examine the consistency of the system of equations in exercises 1 to 6. We're supposed to examine the consistency of the system of equations. Now, how do we go about examining the consistency? One very important thing is that you should be able to write the system of equations in the matrix form. What is that? If you have the coefficient matrix A as this, A1, B1, A2, B2. This is a 2 by 2 system. A1 is coefficient of x in the first equation. B1 is coefficient of y in the first equation, A2 is coefficient of x in the second equation, B2 is coefficient of y in the second equation. The matrix X as this and the matrix B as the right hand side, can you observe that? This is 2, 3. Therefore, this system of equation can be represented in this form, Ax equals B. Okay. And if determinant of A is non-zero, what will happen if determinant of A is non-zero? The inverse will exist for this matrix, yes, A, for this matrix A. And if the inverse exists, let's pre-multiply by A inverse. So this becomes A inverse times A, which is identity, times X will be equal to X. And this becomes A inverse times B. And since the inverse is unique, therefore, this system will have unique solution. Okay, this is the first thing. Now, if determinant of A is equal to 0, then there's something else that you need to find and check first of all. Something else implies you have to check adjoint of A times B, this particular expression. Now this particular expression may not be 0 or it may be 0, right? If this expression over here is not equal to 0, then you can directly comment that the system of equations will not have any solution, and you say that it does not have any solution. System equation has no solution. If it is equal to 0, then you have some idea about the system of equations, but you don't have the complete idea, right? So can you comment fully about this? No. The system of equations may have no solution, or in turn may have infinitely many solutions. Infinitely many solutions. Okay, that is, many values of x, y and z will satisfy the system of equations if that is the case. No value of x, y, z will satisfy if this is the case, and a unique value x, some particular x, some particular y and some particular z will satisfy for this particular case over here. Yes. So, which of these are inconsistent systems and which of these are consistent systems? Consistent means that the system of equations have a solution. That solution may be unique or it can be many solutions. The system of equations should have a solution for it to be consistent, for it to be called consistent, right? So, what about inconsistent? Inconsistent system means the system of equation does not have a solution. So, this is the case for inconsistent, and yes, this is also the case of inconsistent. How do we go ahead in this direction is not something which is in the scope of NCERT. NCERT only talks about this particular thing, let me tell you. They only talk about this particular thing. At max, they will go up to this. But when you talk about this one, What are we supposed to do for the further analysis? In the matrix method, you don't have many choices. Just try to find the solution, and if you can get the solution, you will say, okay, I have some infinitely many solution. Now, infinitely many solution will not be some particular values of x and y and z. What you'll have is you will be able to find the solution in terms of some parameter k. In terms of some parameter k for infinitely many solutions, you can find the solution. And if you are not able to do that, then you will have the case of no solution. Some more idea is required for the system of equations for the last case, and that idea is actually related to something called equation of plane in the three-dimensional geometry. Something related to that? Yes, something related to that. You can get parallel planes, so you can get a lot of things from that. We are not going into the details of all of those things. Right now we are concerned with these type of questions, simple questions where we just need to check the consistency depending upon the values of determinant of the coefficient matrix A. So let's write this system of equation in the requisite form. What do you have? X plus 2y, 2x plus 3y, 2 and 3. So let matrix A is 1, 2, 2, 3. This is a coefficient matrix. Let matrix X is this variable matrix, and the matrix B is made up of these terms on the right hand side 2 and 3. Then you can clearly say that the system, given system, the given system is equivalent to AX is equal to B. And for checking the consistency, we are supposed to begin with this. We are supposed to begin with determinant of A, the value of determinant of A. Check determinant of A. Determinant of A is equal to 1, 2, 2, 3. And this is equal to 3 minus 4, which is minus 1. You can see this is non-zero. If determinant of A is non-zero, then X equal to A inverse B. That is, you get a unique solution. But more importantly, what is asked is whether this is a consistent or inconsistent system. What kind of a system is this? Yes, this here is a consistent system of equations, as you can clearly see behind me. And that's the first question in front of you. Right. We'll move on to the next question after this. Let's discuss this question next. The question says examine the consistency. Once again, a similar question as the first one, and examining the consistency is not a difficult thing. What we can do is we can create a matrix A first of all. That's the coefficient matrix. The matrix A can be formed using the coefficients of X and Y in the first equation, and the second equation it is 1 and 1. And check that determinant of A is equal to 2 plus 1, which is 3, and since this is non-zero, therefore you can clearly say that the system of equations will have unique solution. The solution can be X equal to A inverse B, but more importantly the system is consistent. The system is consistent, and that is what we were interested in, right? So we were only supposed to check for consistency. Are we supposed to find the solution here? No, we are not supposed to find the solution here. In case you want the solution, you can go ahead, create matrix X, this, create a matrix B using the values on the right hand side like this, and therefore capital X is equal to A inverse B. Using A, find A inverse and multiply it with B to get the solution, right? That's what you can do, but that's not required. The only thing that is asked is consistency, and this is what we have answered. Moving on to the next one. This one, once again, examine the consistency that's required. Let's take a look at this one. So, the matrix A can be formed very easily using the coefficients of X and Y from the first equation, coefficients of X and Y from the second equations. This implies determinant of A, and what is that? Determinant of A is equal to 6 minus 6, which is 0. Okay. If this is 0, then you can say that there's an issue, and we'll have to check. For a system of equations involving two equations, you can directly check using your older concepts as well. But using matrix algebra, what you can do is check adjoint of A times B first. What is this equal to? So for this, I'll have to find adjoint of A first of all. Using this matrix A, what is adjoint of A? Adjoint of A for a 2 by 2 matrix is not a difficult thing. It is a very simple thing. You interchange these two diagonal elements and you introduce a minus over here. This is what you have. Let's check the value of adjoint of A times B. What is that? 6 minus 3 minus 2, 1. And B is the matrix on the right hand side using 5 and 8. This is what you have. And what is this equal to? 6 times 5 is 30 minus 24. 30 minus 24 is 6. Minus 10 plus 8 is minus 2. And you can observe that this is non-zero. Adjoint of A times B is non-zero. Yes. If this is non-zero, then we can directly say the system of equations will have no solution. And yes, the system is inconsistent. That's what I will be commenting. The system is inconsistent since this is the case. Remember, don't forget that adjoint of A times B can be 0 as well, right? If adjoint of A times B is 0, then the system can have no solution or infinitely many solutions. In this case, the system will be inconsistent. In this case, the system will be consistent. And both of these begin from this only. So how do we go about checking these things? Frankly speaking, as per the scope of NCERT, this is not something which is important for us for now. But yes, it is checked on the basis of equations by trying to solve the equations, right? That is a simple approach which you can follow for now if you want to go ahead. Other than that, if adjoint of A times B is non-zero, then you can directly say the system equations will have no solution, and yes, it will be inconsistent system. That's all that you have in this question. Moving on to the next one. Fourth, what does this question say? X plus y plus z equals to 1, 2x plus 3y plus 2z equal to 2, ax plus ay plus 2az equals 4. And let's examine the consistency of the system of equations over here. Okay, let's create the matrix A first of all. XYZ coefficients 1, 1, 1, XYZ coefficients 2, 3, 2. XYZ coefficients A, 2A is what I have over here. Is that okay? Yes. Oh, there are a lot of A's over here. Yeah, there are a lot of A's. What can we do? We cannot do much about this. Let's say consistency of this system of equations is being asked. Let's try to find the determinant of A over here. How do we do that? Okay, we have 2, 3 and 2, and you have lots of 1s. What you can do is we can subtract and create some zeros over here. For finding determinant of A will be equal to 1, 1, 1, 2, 3, 2, A, 2A. Okay. And since this is the case, then let's create some zeros. Yeah. This will be equal to, you can say 1, 2 and A will remain as it is. 1 minus 1 is 0, C2 minus C1. And this is again 0. Okay. C3 minus C1 is 0, 0 and A over here. Okay. So let us expand along the first row. 1 times 1 into A is what I'll get. That's simply A, right? And if you observe, although in the question it should be mentioned that, since this is an equation, right? If A becomes 0, everything becomes 0, 0 equal to 4 is not done, right? So here you can observe that A is not equal to 0 should have been mentioned. If it is not mentioned, then you can think what happens in case A is 0, what happens in case A is non-zero. We can think in those terms. But if it is mentioned that A is non-zero, then we can say, okay, this is non-zero and the system of equations will be consistent. In this case, we'll get unique solution. In this case, we'll get unique solution if A is non-zero. That seems okay from here. Right. But if it is not mentioned, can you observe that at this stage, if it is not mentioned that A can be 0, the case when A equals 0 will make this equation 0 equals 4, which is inconsistent. Obviously, 0 is not equal to 4. So the system of equations will be inconsistent in that case, right? If A becomes 0, the system of equations will be said to be inconsistent. As you can clearly see over here, right? Is that okay? Yes, that's the complete question. Otherwise, for A non-zero, we have a unique solution because determinant of A is coming out to be simply A. We have a unique solution in general, right? That's the question. That's a complete solution for you. Let's discuss this question next. The question says, examine the consistency for the system 3x minus y minus 2z equal to 2y minus z is equal to minus 1 and 3x minus 5y is equal to 3. Okay. The system equations can be written properly as 3x minus y minus 2z equals 2. There is no term of x, therefore this is 0 times x plus 2y minus z is equal to minus 1. There is no term involving z, this is 3x minus 5y plus 0 times z is equal to 3. Can we create the matrix A very easily now? Yes. Therefore, matrix A, which is the coefficient matrix, will be 3, 0, 3, minus 1, 2, minus 5, minus 2, minus 1, 0. And can you help me find the determinant of A very easily now? Yes. Determinant of A can be obtained by expanding along the first column, if you can see, right? Okay, so you have 3 and with 3 you get 0 and 0 minus of 5. So minus 5 minus 0 plus 5 times something else, plus 3 times something else. What is that? 1 plus 4 is what I'll get. 1 plus 4 is 5. This is minus 15 plus 15. As you can see, this is 0. Okay, this is 0. Now that makes things interesting. Once we get determinant of A as 0, we'll have to find adjoint of A. Okay, let's go about finding adjoint of A and let's multiply it with B afterwards. So what is adjoint of A? For finding adjoint of A, we'll have to find the cofactors of all the elements over here. Okay, our whole concept of writing the grid. First of all, let me write the grid, and then for this element over here, you have 0 minus of 5, this becomes minus 5. I'm creating the cofactor matrix first of all. This is minus 5. For this element over here, you get 0 and minus of minus 3 will be plus 3, but then there's an extra minus, this becomes minus 3. For this element, you get 0 minus 6. For this element, you get 0 and minus 10, but an extra minus will make it plus 10. What about this? This element, yes, center one, 0 and minus of minus plus 6. There's an extra minus over here and there's an extra minus over here as well. Yes, for this element you get minus 15 plus 3 is minus 12 and extra minus will become plus 12. What about this element? This element is minus 3 and that will become plus 3. Here, for this element you get 6. For this element here you get 1 plus 4, which is 5. This is what I am getting. So these are the cofactors. These are the cofactors of the corresponding elements. Once we have the cofactors, we can create the adjoint matrix very easily. Adjoint of A is equal to the transpose of this, which is minus 5, minus 3, minus 6 over here. 10, 6, 12 over here. And 5, 3, 6 over here. This is what you get. Adjoint of A. And matrix B. Matrix B is nothing but the right hand side elements, that is 2, minus 1, 3. Therefore, adjoint of A times B is equal to what? Minus 5, minus 3, minus 6, 10, 6, 12, 5, 3, 6 times the other matrix, which is 2, minus 1, 3. Can you help me find this product first? Yes. Let's do it. Minus 10 minus 10 again, minus 20 plus 15 is minus 5. Oh, had this been 0, we would have been interested in further solving that, but this does not seem equal to 0. This is not equal to 0, right? Let's find the other two elements as well, but that is not required, as you may see. This is non-zero, implies you will have no solution, and such a case is inconsistent. Such a system is inconsistent. Just for completion purposes, we can also find these values. This is minus 6 again, which is minus 12 plus 9. Minus 12 plus 9 is minus 3 actually. Minus 12 is minus 24 plus 18. Minus 24 plus 18. Minus 24 plus 18 will be minus 6. And you can see this is non-zero. Therefore, this is an inconsistent system over here. The system equation does not have any solution, as you can see clearly. Is that all? Yes, that's all that you have over here. Moving on to the next one after this. Examine the consistency, right? Okay, let's write the coefficients and create the coefficient matrix. A is equal to coefficients of x 5, 2, 5. Second column will be coefficients of y -1, 3 and -2. Third one will be coefficients of z 4, 5, 6. This is what you'll have. Is that okay? Yes, is okay. What else? Can we create some zeros for finding the determinant? Yes, maybe we can subtract this 5 and 5, but that will not take us anywhere very long. Right, so let's find the determinant of A directly. Determinant of A will be 5 times this, expanding along this column over here, 5 times 18 plus 10 is 28. Minus 2 times -6 plus 8. -6 plus 8 is 2. And plus 5 times -5 minus 12 is -17. Okay, so 5 times 28 minus 5 times 17 is 5 times 11 actually, which is 55. This is 5 times 11, which is, let's write 5 times 11 only, minus 4, which is 55, minus 4, this will give me 51. This is non-zero. Since determinant of A is non-zero, therefore there will be a unique solution, and for a unique solution, the important thing is that the system of equations will be, yes, consistent. The system of equations will be consistent. Is that okay? Yes, that's pretty simple. So this is the 6th question for you. Let's discuss this question next. The question says, solve the system of linear equations using matrix method. Yes, the matrix method in exercises 7 to 14. This is the 7th question. Let's see how do we use the matrix method to solve this equation over here. So this is system of equations, and let's write it in the required form, that is Ax equals b. So the coefficient matrix will be formed using the coefficients of x and y. 5, 2 in the first equation, 7, 3 in the second equation. Then you have x equals xy, this is a variable matrix, and then you have the right hand side, that is matrix B, which is this matrix over here. Okay, once you're clear with this, can you observe that determinant of A can be found very easily. Therefore, system of equations, let's note that system of equations is Ax equals b. System of equation has been written in this form, right? If A is this, x is this, y, b is this, then Ax equal to b represents that system of equations, or alternatively that system of equation is represented by this Ax equal to b. What about determinant of A? Now let's talk about determinant of A, that is 15 minus 14, and 5 3 15 minus 7 times 14 is 1, which is non-zero, and therefore will have unique solution. Therefore unique solution will exist. Okay, since you'll have unique solution, let's see. Let's try to find that solution. So Ax equals b tells me that x will be equal to A inverse b if inverse exists, that is when A is non-singular, that is determinant of A is non-zero. Therefore A inverse exists. Yes, let's find A inverse, where A inverse is equal to 1 over determinant of A times adjoint of A. Okay, and what is adjoint of A? For a 2 by 2 matrix, finding adjoint of A is not at all difficult. We can simply interchange the elements in the main diagonal, and other elements will have an extra minus in front of them. This is 1 upon 1 times the adjoint of A is pretty simple. You'll interchange 3 and 5. This will become 3, this will become 5, and 7 and 2, you'll introduce an extra minus over here. This is what you'll get. Okay, so A inverse is pretty simple. Yes, this is 3 minus 7 minus 2, 5, which is simple. Next, therefore, x equals A inverse B, which implies that this matrix xy is equal to A inverse, which is this, times B. B is this matrix 4, 5. Yes. Let's multiply these two matrices and see where does that take us. 3 times 4 is 12, minus 10 is 2. Is that okay? Yes. Minus 28 plus 25 is minus 3. This is the matrix xy, and this is equal to this matrix, which implies x equals 2, y equals minus 3. That is my answer, as you can see behind me over here. x equals 2 and y equals minus 3 is what I get. For the timing, you can also check your answer for a minute. What do you have? In the LHS, 2 and minus 3 will give me 5 times 2 is 10 and minus 6 will be 4. That's okay. 7 times 2 is 14, minus 9 is 5. That's okay, right? Both the equations are satisfied? Yes. This is the answer, the correct answer, x equal to 2 and y is equal to minus 3. That's the complete solution of this question over here. Next, let's move on to the next question. The next question is again a 2 by 2 system, right? 2 by 2 system, yes. 2 equations and 2 unknown system. Let A matrix is this matrix, coefficients. Let the matrix B is this. Let the matrix X be X, Y. Once I have this much information, therefore system of equations is actually AX equals B is the given system. And solution can be found if determinant of A is non-zero very easily. Let's check determinant of A is equal to 8 plus 3, which is 11 using this, right? This is okay. This is non-zero. This is non-zero. Therefore, unique solution will exist. And how will we find the solution? Unique solution. That is, X equals A inverse B is the unique solution that we are looking at, looking forward to. And for finding A inverse, we need the adjoint of A. Let's find adjoint of A. Adjoint of A will be equal to, you can interchange the elements along the main diagonal 4 and 2. Introduce an extra minus, this will become plus 1, this will become minus 3 over here from here, right, using this. Okay, since adjoint of A is this, therefore A inverse 1 over determinant of A times adjoint of A is equal to what? Determinant of A is 11, 1 over 11 times this 4, 1 minus 3, 2 is what I get. Okay, A inverse is found. This gives me X equals A inverse times B, which is equal to 1 upon 11, okay, 4, 1 minus 3, 2 times the other matrix, that is B. B matrix is that minus 2, 3 equals 1 by 11, okay, and this product 4 times minus 2 is minus 8, 1 times 3 is 3, minus 8 plus 3 will be minus 5, okay. And you have minus 3 times minus 2 is 6 and 2 times 3 is also 6, 6 plus 6 is 12. Okay. And this here is equal to what? The matrix X is X, Y. Can you observe therefore small x will be nothing but minus 5 by 11, minus 5 upon 11 actually. Or you can multiply it with 1 upon 11 and see this 12 by 11. Okay. So X equal to minus 5 by 11 and Y is equal to 12 by 11. Okay. You're getting fractions over here. Never mind. Let's check the values. This is minus 10 by 11, minus 12 by 11. Minus 10 minus 12 is minus 22 by 11, which is minus 2, which is okay. Minus 15 by 11 plus 48 by 11. 48 minus 15 is 33 by 11, which is 3. That's okay, right? So we have checked the answers. Yes, we have checked the answer. This is the correct answer for this question, as you can see behind me. Is that all? Yes, that's all that you have in this question. Moving on to the next one. Let's solve this question. The ninth one, 4x minus 3y equals 3, 3x minus 5y equals 7. The approach, it's same, right? We write the matrix A first, 4, 3, the coefficient matrix, minus 3, minus 5. We write the matrix X, which is the variable matrix, x, y. We write the matrix B, which is the right hand side. This is 3, 7. Is that okay? Yes. And the system of equations is actually AX equals B. Okay, that's not an issue. For checking the number of solutions or for finding the solutions, we'll have to check whether determinant of A is 0 or not. This is 4, 3, minus 3, minus 5. What is that? Minus 20 plus 9, which is minus 11. Since this is non-zero, therefore you'll have a unique solution. Therefore, unique solution will exist. And what is that unique solution? Unique solution is, which implies X equals A inverse B. Okay. I can find the unique solution if I know A inverse. For finding A inverse, I'll need the adjoint of A. Yes. Let's begin with the adjoint of A. Adjoint of A will be equal to, for that matrix, interchange the diagonal elements, minus 5, 4. And this will become 3, this will become minus 3. Right? We have introduced extra minus over here, this becomes 3, this becomes minus 3 over there. We are not interchanging them, we are introducing extra minus, right? So adjoint of A is known, therefore A inverse is 1 over determinant of A times adjoint of A. Okay, implies X equals A inverse times B. What is that? 1 upon determinant of A, 1 upon minus 11. Okay, adjoint of A will be this minus 5, 3, minus 3, 4. And the matrix B is there, 3, 7, right? Let's multiply them together. This is minus 1 by 11 times, what is this? Let's focus on this. Minus 15 plus 21. Minus 15 plus 21. 21 minus 15 is 6. Minus 9 plus 28. 28 minus 9 is 19. Actually, this is what I'll be getting. This is the value of X, Y, this matrix. Therefore, X becomes equal to minus 6 upon 11. Y becomes minus 19 upon 11. And since this is a question involving solution of equations, don't forget to check your answer. Let's check the answer as well. Minus 6, this becomes minus 24, and 3 times 19 is 57. Minus times minus will become plus. 57 minus 24. 57 minus 24 is 33. 33 upon 11 is 3. That's okay. Minus 18 times 11. 3 times x is minus 18 upon 11. And minus 19 times 5 is 95. 95 minus 18. What is 95 minus 18 is 77. 77 upon 11 will be 7. That's okay. Yes, this is correct answer. Why make a mistake for solving this complete question when you can easily check the answer, right? So let's not worry too much about making a mistake. We'll check the answer and we'll be done, right? That's the complete solution of this question. Moving on to the next one. 5x plus 2y equals 3. 3x plus 2y equals 5. Let's solve this one. The approach is once again pretty simple. Matrix A is the coefficient matrix. This is 5, 2, 3, 2. Matrix X is the variable matrix X, Y. Matrix B is this coefficient matrix which is 3, 5, constant matrix. Okay, and the system of equations therefore is AX equals B, where determinant of A can be found easily. This is 10 minus 6, which is 4, and since this is non-zero, you will have unique solution. Therefore, unique solution. And what is that unique solution? Unique solution, that is the value of X. X equals A inverse times B. And what is A inverse? X equals A inverse times B. And what is A inverse? A inverse is 1 upon determinant of A times adjoint of A times B. Okay. Therefore, X equals 1 upon determinant of A, which is 4. Adjoint of A is pretty simple. Yes, we have been finding adjoint of A for a very long time now. For a 2 by 2 matrix, 2 and 5 interchange, and 3 and 2 will have an extra minus. B matrix is this 3, 5. 1 by 4 is okay. This X is this over here. Right? Yes. Let's multiply these two together. 6 minus 10 is minus 4. Minus 9 plus 25. 25 minus 9 is 16. This becomes minus 1 and 4 over here. So therefore, X equals minus 1, Y equals 4. That should be the answer of this question. But don't forget to check your answer. It's very easy to check. 5 times minus 1 is minus 5 plus 8. Minus 5 plus 8 is 3, which is okay. And minus 3 plus 8 is also okay. That's also okay. And this is done. This is the final answer for this question. Yes, that's the final answer for this question. Okay. Let's move on to the next one after this. Right? 11th. We have 3 equations and 3 unknowns. Okay. That will make things interesting. Slightly, but not very much. We know the approach of solving such questions, right? Let's make the coefficient matrix first. A equals this. Coefficients of x, y, z 2, 1, 1. Coefficient of x, y, z 1, minus 2, minus 1. Coefficient of x is 0, y is 3, and my z is minus 5. Let's take the variable matrix next, x, y, z. And the constant terms will form this matrix. 1, 3 by 2 and 9. This is what I have. The constant terms will get this matrix, right? What next? The system of equations is actually, therefore system is actually Ax equals B, and for checking the number of solutions, we'll have to check determinant of A. Determinant of A is equal to, you can see, 2, 1, 0, 1, minus 2, 3, okay, 1, minus 1, minus 5. What next? We can expand this determinant along this first column, as you can see, or we can create some more zeros for that matter. Let's, should we create some more zeros? Yeah, let's do that. What we can do is multiply this by 2 and subtract over here. This will be 0, okay. This will become multiply this by 2 and subtract over here will be 1 plus 4, which is 5, 1 plus 2, which is 3, okay. You have a 1 minus 2 minus 1 over here, and you have a 0, 3 minus 5 over here, right. This is what you have. Expanding along this first column will imply minus 1 times this. Minus 25 minus 9 is what is required over here. Can you please note that? Minus 25 minus 9 is required over here, and that will be equal to what? Minus 34 plus 1, this is 34 simply. Is that okay? Yes. This is the value of determinant. Since this is non-zero, therefore you can say that there will be a unique solution. And what will that unique solution look like? That unique solution will be x equals A inverse B, which implies x will be equal to 1 over determinant of A times adjoint of A times B. Right or not? Yes. Now, we already have the B. We have determinant of A. What else do we need? We need adjoint of A. So for finding adjoint of A, let's write the cofactor matrix first of all. And cofactor matrix can be found with the help of this grid. Right? With the help of this grid. Is that okay? Yes. Let's write the cofactor of this element. What is that? 10 plus 3, which is 10 plus 3 is 13. This is 13. Okay. For this element, the cofactor is this and this, minus 5 minus 3. What's that? Minus 5 minus 3 would imply minus 8. And there's an extra minus over here that will become plus 8. Is that okay? Yes. Yes. What about this element 0 over here? This is minus 1 and plus 2. Minus 1 plus 2, 2 minus 1 is 1 over here. What else? For this element, you get minus 5 and that's it. And extra minus will become plus 5. There's an extra minus over here and here as well. Okay. For this element, you have 3 minus 0. For this middle element, you have minus 10 and 0. For this element you have 6 minus 0. There's an extra minus. For this element over here you have minus 2 minus 1, which is minus 3 plus 3. Okay. For this element, you have minus 4 minus 1, which is minus 5. This is a cofactor matrix. Therefore, adjoint of A can be found very easily. Therefore, x equals 1 upon 34 determinant of A times adjoint of A, which is the transpose of this 13, 5, 3. The first row will become the first column. The second row will become the second column. The third row will become the third column. And matrix B, as you can see, is 1, 3 by 2, 9. Multiplying them together will give me this matrix. And what's that? Let's multiply these together one by one. 13 times 1 is 13. 8 times 3 by 2 is 12 and 9. 13 plus 12 plus 9 is what we are interested in. 13 plus 12 is 25 plus 9 is 34. Okay. Next, this row multiplied with this column. 5 minus 15 is minus 10 plus 27. Minus 10 plus 27. 27 minus 10 is 17. Right? Next, 3 minus 9 is minus 6 and minus 45. Minus 51 is what I'll get. Okay. And 1 by 34 is there, which is weight. Okay, 1 by 34 is also here. 1 by 34. Let's divide with that. And then, therefore, this gives me actually x, y, z. This is equal to what? This is equal to 34 upon 34, 1. 17 upon 34, which is 1 by 2. And minus 51 upon 34, which is minus 3 by 2. Which implies the values of x, y and z will be x will be 1, y will be 1 by 2 and z will be minus 3 by 2. The important thing which remains is that you should check the values. Let's check values one by one. First equation becomes 2x plus y plus z. 2 plus y plus z is minus 1. 2 minus 1 is 1, which is okay. X minus 2y minus z. X 1 minus 2 times 1 by 2, which is 1. 1 minus 1 is gone. And minus z will be 3 by 2, which is also okay, right? 3y minus 5z. 3 by 2 plus 15 by 2 is 18 by 2, which is 9. That's okay. So this answer is perfect, right? That's the correct answer for this question, as you can see behind me, right? That's all that you have overhead. Let's move on to the next question after this. X minus y plus z equals 4, 2x plus y minus z equals 0, minus 3z equals 0, x plus y plus z equals 2. And how do we go about solving this one? First, we'll create the coefficient matrix A. Coefficients of x are 1, 2, 1. Coefficients of y are minus 1, 1, 1. Coefficients of z are 1, minus 3, 1. The matrix X is x, y, z, and the matrix B is this 4, 0, 2. Once you have all of this together, then what next? Since you have Ax and B, this equation, the system of equation is Ax equals B. The system of equations will have solution depending upon the value of determinant of A. So let's find determinant of A. What is that? 1, 2, 1, minus 1, 1, 1, 1, minus 3, 1. Okay, and we can create some zeros over here very easily. Let's see, a direct subtraction would help in case of this minus 1, right? This minus 1 added to this minus 1 added to this will make them 0. So, C1 plus C2. C1 is replaced by C1 plus C2, which will become 0, 3, 2. This remains as it is, and C3 is also replaced by this. This is 0, minus 2, and then you have a 2 over here. This is what you have. Once again, after this, you can expand along this row, and minus or minus 1 will become plus 1 times 6 plus 4, which is simply 10. If you observe this carefully, determinant of A is simply 10, which is non-zero. Since determinant of A is non-zero, therefore you can say that the equation has a unique solution. Therefore you can say unique solution exists. And what's the unique solution? Unique solution can be represented as x equals A inverse B, which says that x equals 1 over determinant of A times adjoint of A times B. You can find adjoint of A by finding the cofactors first of all, and let's focus on finding the cofactors separately. Using this grid, we'll use this grid to find the cofactors of each and every element over here. There will be extra minus at these locations. Okay, for this one, you have 1 plus 3, which is 4. For this one, you have 2 minus 1, which is 1. For this one, you have 1 plus 2, which is 3. For this one, you have 3 minus 1, which is 2. For the center one, you have 1 minus 1, which is 0. What about this minus 1? You have 2 plus 3, which is 5, and there's an already minus over there. For this minus 3, 1 plus 1, 2. For this, you have minus 3 minus 2, which is minus 5, it becomes a plus 5. For this 2, minus 1 minus 2, minus 1 minus 1 will become minus 2, this will be plus 2. Therefore, this gives me adjoint of A is equal to what? This matrix over here. Transpose of this 4 minus 5, 1, 2, 0, minus 2, and 2, 5, 3 is what I get. Once I know this much, therefore, x will be equal to 1 upon determinant of A, 1 upon 10. Adjoint of A, 4 minus 5, 1, 2, 0, minus 2, and 2, 5, 3 times the matrix B. What is the matrix B? 4, 0, 2. This is equal to 1 by 10 times this matrix over here. And can you help me find this matrix? Yes. This times this, which is 16, 0, and 4, 20. Minus 20, 0, and 10, which is minus 10. 4, 0, and 6, 10. Okay. So this gives me that the matrix X, Y, Z is equal to the values over here, 20 by 10, 2, minus 1, and 1. Therefore, X equals to Y equal to minus 1, and Z equal to 1. This gives me that's the required answer. But given the system of equations, you can always check your answer Let's do that. 2 minus 1, 1. 2 plus 1, 3 plus 1, 4. Right? What is 2x plus y plus minus 3z? 2x is 4 plus minus 1, which is 4 minus 1 is 3. Minus 3 will be 0. Right? Second equation is also true. The sum of all three will be 2. That's a third equation, which is also true. Satisfied. Therefore, this is the final answer. That's a complete solution of this question over here. Let's move on to the next one. This. 2x plus 3y plus 3z equals 5. X minus 2y plus z equals minus 4. 3x minus y minus 2z equals 3. And let's solve this equation. This system of equation. The matrix A is 2, 1, 3, the coefficients of x. Coefficients of y 3, minus 2, minus 1. Coefficients of z 3, 1, minus 2. X is this matrix and B is this matrix. Okay. Therefore, the system of equations is Ax equals B and the solution depends upon the determinant of A. Let's find the determinant of A. Determinant of A will be 2, 1, 3, 3 minus 2 minus 1. This is what you have. Can we create some zeros over here? Yes, maybe. We can create some zeros. How do you think we can create zeros? We can use this 1 to subtract twice of this and thrice of this from R1 and R3 respectively. Or another idea is to use this minus 1 with this 3, add over here and you get a 0 over here. But you will not get a 0 over here. You can get another 0 over here at this stage. Okay, and can we get 2 zeros simultaneously? No, 2 zeros simultaneously are not possible. So let's use R1 replaced by R1 minus 2R2. R2 remains as it is. And twice of this is subtracted from A. 2 minus 2 will become a 0. 3 minus of minus 4 will become 7. 3 minus of 2 will become 1. R3 is replaced by R3 minus 3R2. R3 minus 3 times this will become 0. This minus 3 times this is 6 and 6 minus 1 is 5. 3 times this is minus 2 minus 3 which is minus 5. This is what you have. Is that okay? Yes. So this becomes 0 plus this is minus 1 times you get minus 35 minus 5 which is minus 40. This is equal to 40 and yes, since this is non-zero, therefore you will get a unique solution. And what's that unique solution? X equals A inverse B is the unique solution that you will get. Okay. This gives me X equals 1 upon determinant of A times adjoint of A times B. And for that we need adjoint of A. We already know determinant of A, we know matrix P. We will require adjoint of A. So for finding adjoint of A, what do we need? Oh, we need to find the cofactor matrix of this matrix over here. And let's do that. Let's do that. Let's create our grid. Yes, fancy grid. And that is how it will help us. So for this element, this is 4 plus 1, which is 5. For this element, you have minus 2 minus 3, which is minus 5. This becomes a plus 5. This element, you have minus 1 plus 6. 6 minus 1 is 5. Okay. For this element, you have minus 6 and plus 3. Minus 6 plus 3 is minus 3. This becomes a plus 3. For the central element, you have minus 4 and minus 9, which is minus 13. Okay. The last element over here, this minus 2 minus 9 is actually minus 11. So this becomes plus 11. Yeah, plus 11, right? What about this element over here? 3 plus 6 is 9. Excuse me. This element is 2 minus 3, which is minus 1. That becomes plus 1. Minus 4 minus 3 is minus 7. So this is a cofactor matrix. The adjoint will be transpose of this. 5, 5, 5. 3 minus 13, 11. 9, 1 minus 7 is what I get. Okay. So therefore, using that item in the box, what do we write? Therefore, X is equal to 1 over determinant of A, which is 1 over 40, times adjoint of A, which is 5, 3, 9, 5 minus 13, 1, 5, 11, so minus 7. This times another matrix which is matrix B. Matrix B, that is here, 5 minus 4, 3. Let's multiply them together. 1 over 40 is okay. What do we get as the first element of this matrix? This is 3 by 3, this is 3 by 1, this will be 3 by 1, right? 5, 3, 9 multiply with this. 5 times 5 is 25, minus 12 is 13, plus 27 is 40. So this is 40. What next? 25 plus 52 is 77 and plus 3 is 80. Next, 25 minus 44 and minus 21 as well, okay. Minus 44 minus 21. Minus 44 minus 21 will be minus 44, 70, 65, yes. And plus 25. 25 minus 65. 25 minus 65 is minus 40, I suppose. Yes, this is minus 40. Let's check that again. 25 minus 44 is minus 19 and minus 21. Minus 19 minus 21 is minus 40, yes. Okay, so therefore, this gives me that this matrix X, Y, Z is equal to this matrix over here, 40 divided by 41, 2 and minus 1. This gives me X equal to 1, Y equal to 2, Z equals to minus 1. And don't forget to check your answer. So, X equals to 1, Y equals 2, Z equals minus 1 is the answer. We'll check that. 1, 2 and minus 1. 2, 6, minus 3. 8 minus 3 is 5. First equation is okay. Second equation, 1, minus 4 is minus 3. And then you have minus 1. Minus 3 minus 1 is minus 4, which is there in the RHS. The third equation, 3, minus 2 is 1. And plus 2 is 3. That's the third equation, also satisfies. So therefore, this is the correct answer. You can take a look at the complete solution. That's all that you have in this question. Let's move on to the next one after this. 14th. What does this question say? X minus y plus 2z is equal to 7. 3x plus 4y minus 5z is equal to minus 5. 2x minus y plus 3z is equal to 12. So, how can we approach this question? Approach is similar. Once again, these are just practice questions. So, matrix A can be found very easily. 1, 3, 2. Okay. Minus 1, 4, minus 1 and 2, minus 5, 3. Matrix X is again very simple. X, Y, Z. Matrix B is the constants on the right hand side. This is 7, minus 5 and 12. So, the system of equation that you have is AX equals B. And the solution will depend upon the value of determinant of A. Let's check the value. Determinant of A will be equal to what? Let's multiply 1. X expand along the first column. 1 times 12 minus 5 is 7. Is that okay? Yes. Minus 3. Minus 3 plus 2 is minus 1. Plus 2 times, what do you have? 2 times 5 minus 8 is minus 3. Right? Okay. And this will be 7 plus 3, 10. 10 minus 6 is 4. This is 4 and 4 is non-zero. Therefore, you'll have unique solution, and that unique solution can be found using X equals A inverse B. Okay. X equals A inverse B, or you can say that X equals 1 upon determinant of A times adjoint of A times B. The important thing is that you don't know the value of adjoint of A. Let's find adjoint of A you give for the given matrix. We'll have to draw the grid. So there will be extra minus over here. Let's find the adjoint of each of these elements. The adjoint matrix by finding the cofactors of each element first of all. For this, you have 12 minus 5, which is 7. You already found that, right? For this matrix, you have minus 3 and plus 2. Minus 3 plus 2 will be minus 1, and there's an extra minus, so this becomes plus 1. For this, you have 5 minus 8, which is minus 3. Okay, we used all of these things over here. Next, for this element, you have 9 plus 10, which is 19. Okay, so this is 19 over here with an extra minus, right? 9 plus 10. Okay, for this too, you have minus 3 minus 8. Minus 3 minus 8 is minus 11. Okay, for this element over here, this element you have 3 minus 4, which is minus 1. For this element over here, you have minus 5 minus 6 minus 11, it becomes plus 11. For this element over here, you have minus 1 plus 2. 2 minus 1 is 1. And since there is an extra minus, this is what you get. For this element you get 4 plus 3 which is 7. Using this you can write adjoint of A very easily. It is a transpose of the cofactor matrix 7 minus 19 minus 11. 1 minus 1 minus 1. Minus 3, 11, 7. This is what you have. Next, therefore, the matrix X is equal to 1 upon determinant of A, 1 upon 4 times adjoint of A times the matrix B. What is the adjoint of A? This is 7, 1 minus 3. Minus 19, minus 1, 11 and minus 11, minus 1, 7. What is the matrix B? This 7 minus 5, 12. This is further equal to 1 by 4 times something. What is that? Let's multiply these two and see where does that take us. So 7 times 7 is 49, minus 5 is 44 and 44 minus 36 is it? 44 minus 36 is 12. Okay, 44 minus 36 is 12, right? This is what you have. Is 8 actually, it's not 12, it's 8. 8. Okay, let's not make a mistake on that. Minus 19 times 7. So 19 times 7 will be 140 minus 7 which is minus 133. And plus 5 is minus 133 plus 5 is minus 128. And what's that? This is 11 times 12 which is 132. 132 minus 128 is 4. Okay, that's simple. Then you have minus 77 plus 5 which is minus 72 and 84. 84 minus 72 is 12. This is okay. So this becomes equal to 2, 1, 3. Therefore, X is equal to 2, Y is equal to 1 and Z is equal to 3. And it's very important that you check your answer. Let's check. X equal to 2 will imply 2 minus 1 is 1 and 6 is 7. The first equation is correct, okay. The second equation, 6 plus 4 and minus 15. 6 plus 4, 10 minus 15 is minus 5. Second equation is also correct. 4 minus 1 is 3 plus 9. 3 plus 9 is 12. The third equation is also correct. Yes, this is the correct answer for the given question, right? That's all that you have over here. Let's move on to the next question after this. 15th. 15 says, if A matrix is equal to this, find A inverse. First find A inverse. Using A inverse, solve the system of equations. Now, if you observe carefully, what is this matrix A? 2 minus 3, 5 are the coefficients. 3, 2 minus 4 are the coefficients. 1, 1 minus 2 are the coefficients. Basically, you are given that coefficient matrix directly and you are asked to find the inverse first of all. So, let's go about finding the inverse for this A. A equals this matrix 2, 3, 1, minus 3, 2, 1, 5, minus 4, minus 2. For finding the inverse, we'll have to check whether determinant of A is 0 or not. Determinant of A is equal to what? Determinant of A will be equal to 2 times, this is minus 4 plus 4 which is 0, okay, minus 3 times, expanding along the first column, 6 minus 5 which is 1, okay, plus 1 times 12 minus 10 which is 2. Okay, this becomes minus 3 plus 2 which is minus 1. Since this is non-zero, the determinant, since the determinant is non-zero, therefore the inverse will exist. Okay, therefore A inverse exists. And how do we find the inverse? By finding the adjoint. So therefore A inverse is equal to 1 over determinant of A times adjoint of matrix A. Now how do we get the value of adjoint? Adjoint is very simple. If you can find the cofactor matrix, you can easily get the adjoint. So let's find the cofactor matrix. There will be minus, minus, minus and minus at these locations, extra minuses, right? Begin with this one. This is minus 4 plus 4 is 0. We use that, right? For this, you have 6 minus 5. 6 minus 5 which is 1. This becomes minus 1. For this, you have 12 minus 10 which is 2. That's okay. For this term, you have minus 6 plus 4. Minus 6 plus 4 is minus 2. This becomes a plus 2. For this, you have minus 4 minus 5 which is minus 9. For this, you have minus 8 and minus 15 which is minus 23. That becomes plus 23. Let's take that. Minus 8 and 15. 23, right? For this, you have 3 minus 2 which is 1. For this, you have 2 plus 3 which is 5. This becomes a minus 5. For this, you have 4 plus 9 which is 13. That's what you have. This is the cofactor matrix, therefore adjoint. Adjoint of A is pretty simple. Adjoint of A is the transpose of that cofactor matrix 0 to 1. minus 1, minus 9, minus 5. Then you have 2, 23, 13. This is what you have. Adjoint of A is this. Is that okay? Yes. Once we are clear with the adjoint of A, we have determinant of A. Therefore, A inverse can be easily found. A inverse is equal to what? A inverse is 1 upon determinant of A, 1 upon minus 1 times this matrix over here, which is equal to the same matrix. And this will be equal to, let's multiply that minus inside. So what you get is 0, minus 2, minus 1, 1, 9, 5, and minus 2, minus 23, minus 13 is what I'll get over here. Is that okay? Yes. That's the inverse. The first thing that we wanted was that inverse. Okay. Now once you have found the inverse, do you observe that solving the system of equations is pretty simple. For the system of equations, A is already known. Ax equal to B is the system of equations where A is given, x is equal to this, x, y, z, and B is equal to this matrix over here. 11 minus 5 minus 3. Okay, this is known. And therefore, x is equal to A inverse times B, which gives me this matrix. X, y, z is equal to A inverse. A inverse is this matrix times B is the other matrix. Let me write the values carefully for the matrices. This is B, which is 11 minus 5 minus 3. What's A inverse? A inverse is this matrix, 0, 1, minus 2. Minus 2, 9, minus 23, and minus 1, 5, minus 13. This is what you have. Is that okay? Yes. Let's multiply them together and see where does that take us. The product will be 0 times 11, which is gone, minus 5 and plus 6. 6 minus 5 is 1. Okay. Minus 22, minus 45. Okay. Right. So, minus 22 and 45, what will that be? Minus 45, 22, 67 is what I'm getting, right? 22 and 45, 67, minus 67, plus 69. 69 minus 67 is 2, okay. Minus 11, minus 25 is minus 36, and 39. 39 minus 36 is 3, not 4, it's 3, right? 39 minus 36 is 3. Therefore, x equals 1. Y equals 2, Z equals 3, okay. And let's verify this. This seems to be the answer, but let's check the answer. How will we check? We'll have 1, 2 times 1, first equation, 2 minus 6 is minus 4 and 15. 15 minus 4 is 11, first equation seems okay. What was second one? 3 times 1 is 3, plus 4 is 7, and minus 12. 7 minus 12 is minus 5, which is also okay. 1 plus 2 is 3, minus 6 is minus 3, that's also okay. Yes, therefore this answer is correct, as you can clearly see over here. Is that all? Yes, that's all that you have in this question. Moving on to the next one after this. This, okay, a word problem. Yes, a word problem based on matrices and determinants solving system of equations. So the cost of 4 kg onion, 3 kg wheat and 2 kg rice is rupees 60. The cost of 2 kg onion, 4 kg this, 6 kg this is 90, 6 kg this, 2 kg this, 3 kg this is 75. Cost of each item per kg by matrix method. You know what are the unknowns. You can form the equations and then solve for the unknowns. What are the unknowns? The prices, cost of each item. Let cost of each item. Let cost of onion be rupees X per kg. Wheat be Y per kg, and rice be KZ per kg, right? Similar things. So rupees per kg, per kg, per kg, right? Therefore, the equations formed will be 4 kg onion, 4x plus 3y plus 2z is equal to 60. That's the first equation. Let's form the second equation after this. 2 times x, 4 times y and 6 times this. 2x, 4y plus 6z is equal to 90, I suppose. This is 90, yes. Onion, wheat and rice, once again 6x, 2y, 3z. Is equal to 70. That's given, right? Those are the equations that we have, okay. And For solving these equations, obviously we'll need the matrix of coefficients, right? So A is equal to this matrix over here, 4, 2, 6, 3, 4, 2, 2, 6, 3. X is this matrix, X, Y, Z, and B is this matrix, 60, 90, 70. Okay, therefore system of equations is AX equals B, and if determinant of A is non-zero, then we can find a unique solution. Right, let's check determinant of A. What is that equal to? Okay, for determinant of A, we have this over here, 4 times, let's multiply, 12 minus 12, which is 0. Okay, minus 2 times, 9 minus 4, which is 5. Okay, and plus 6 times, 18 minus 8 is 10. So this is 60 minus 10, which is 50. And since this is non-zero, therefore unique solution exists for the system of equations. And what's the unique solution? X equals A inverse B. For finding the A inverse, we will need adjoint of A. So let's find adjoint of A first of all. And adjoint of A can be found with the help of this grid. Yes. Okay, this is a minus, 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 and a minus extra over here. For this matrix, let's find the cofactor matrix. This is 12 minus 12 is 0, okay, and then we began with this. This is 9 minus 4, which is 5. This becomes a minus 5. For 6, you have 6, 3, 18 minus 8 is 10. That is something which we have already used. Next, for this, you have 6 minus 36. 3 times 2 is 6 minus 36 is minus 30. So this becomes plus 30. For this element, you have 12 minus 12, which is again 0, okay. For this element, you have 24 minus 4 is 20. You have a minus, therefore this becomes minus 20. For this element, you have 4 minus 24, minus 20. This element is 8 minus 18. 8 minus 18 is minus 10. This becomes a plus 10. For this element, you have 16 minus 6 is 10. This is what I get. This gives me adjoint of A is equal to what? The transpose of this, 0, 30, minus 20, okay. Then you have the next row, which is again minus 5, 0, 10, the transpose of this. Then you have 10 minus 20, 10, okay. You have adjoint of A now. Okay. Therefore, X is equal to, X is equal to A inverse B, which is equal to 1 upon determinant of A times adjoint of A times B. Okay. The matrix X is X, Y, Z. Let's substitute that. Determinant of A. Did we find determinant of A somewhere? Yes, that's equal to 50. This becomes 1 over 50. Adjoint of A. Adjoint of A is this matrix. 0, 30, minus 20, minus 5, 0, 10, 10, minus 20, 10. What's the matrix B? Matrix B is this matrix over here, 60, 90, 70. Okay. And what's the product? This is 1 by 50, which is okay. The product of these two matrices can be found. This is 0 times 60, which is gone, minus 5 times 90, which is minus 450, and plus 700. 700 minus 450, or you can imagine that these zeros can be added at the end. This is minus 45 plus 7. Plus 70, is it? Plus 70, yes. So minus 45, 70 minus 40, this is 25, 250 is what I'm getting. Okay, next. 18, 180 actually. Or 6 times 3 is 18, 18 into this is important, right? 180 and 1800, this is 1800, 90 is gone, and minus 1400. 1800 minus 1400 is 400. Okay, let's use that zeros also. This is minus 1200 plus 900 is minus 300, minus 300 plus 700. 700 minus 300 is 400, right? So this is 400 again. So this gives me X, Y, Z over here is also equal to what? 5 and 8 and 8. This gives me X equals 5, Y equals 8, Z equals 8. Or in other words, you can say that the price of onion is rupees 5 per kg, the price of wheat is rupees 8 per kg, and the price of rice is rupees 8 per kg again. Don't forget to check the result, check the equation solution that you have obtained 5, 8 and 8 for the original one. So 4 times 5 is 20, first equation 20 plus 24, and this both of these are 8, right? 5 times 8 is 40, 40 plus 20 is 60, first equation is okay. Then you have 4 plus 6 is 10, 10 times 8 is 80, and you have 10, 90, which is okay. 5 times 8 is 40, 40 and 6 times 5 is 30, then you have 70, that's also okay. So yes, this is the correct answer, and that's all that you have in this question over here. Check the complete solution behind me, and that's all for this question. With this, we come to the conclusion of this exercise based on determinants. This is exercise number 4.6. As you can see, this is exercise number 4.6, which was based on solution of system of equations. If you have enjoyed watching these solutions with us, and if you have learned some things from here, please like and share this video, and also subscribe to the channel of Vyas Edification if you haven't done it yet. Right. We'll meet in the next session to discuss another exercise from the chapter Determinants. Till then, all the best.